Okay, we're going to repair this DDX 9101. This is the one on the bottom, and I'm using the one on the top to provide the signals to check the one on the bottom. We've got a signal generator also we're going to use later. So the first thing I'm doing is connecting the output of the top one. The calibration output of the top one is set to 50 PC. That's looped into the back into this one, and you can see the two pulses there. That's set to 2 pulses, and you can see the 2 pulses there and there, and they're still not moving on the phase, which means that they're referenced to the mains frequency. The kilovolt meter is 0, so it can't reference to the input frequency. It's got to reference to the mains supply frequency, which is why they're still. So first thing I'm going to check is the ranges are working and that the input attenuators are all good. So we see we're on the 5 dB range now, and the pulses are a nice size. I'm putting in 50 PC, but this is reading 20 PC. So it's not calibrated yet, but before I calibrate, I will just check that the sizes of the pulses change as I change the range. So if we look at the pulses, we're going to go bigger, and they go bigger, and if I go the other way, they're going to get smaller, 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 until they disappear. Just make sure they come back when I increase the signal. And you see they're just very small coming back there. Smaller again. Bigger, 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 bigger. So that's all working, the ranges are working. Back to 50 PC. Now the reported fault on this one was that the manual calibration is not working. So this is all working. I'm going to demonstrate that. Again, we put 50 PC. I've got 50 PC here. This is reading 20, so it's not being calibrated yet. So main menu, calibrate, manual calibration, set that to 50. Okay. Attach the calibrator to the test circuit and switch it on. Okay. And now it's set to 50. So that's calibrating correctly. I'll just change range. 10 dB. Still reads 50. 15 dB. Still reads 50. So that's good. And the other fault that was reported was it's not synchronizing properly to the input frequency. So this is a signal generator set to close enough to 50 Hz, and this is going to be fed into the kilovolt meter. So as I switch that on, you can see we start to get some voltage there. Got 90 kV, I'll just increase that. Thankfully it's not really 90 kV. 300 kV, getting nice and big. And what you can see is these pulses now are not referenced to the mains, they're not still, they're now moving along. And the reason is because the frequency is not exactly the same as the mains input. We've got 49.7 Hz, almost 50 Hz. So the pulses just move along very slowly. And what I'm going to do now to demonstrate this, if you look at these pulses here, you see they're moving slowly. And what I'm going to do now is change the frequency on the frequency signal generator, and as I do that, these pulses are going to move more quickly. And there they go. Which means it's referencing to the frequency that I'm inputting, not to the main. There they go. They're still, because they're on a multiple of 50, they're actually on 40 Hz. And now they start to move again. So as I sweep the frequency on the kilovolt meter here, the pulses will reference to the new frequency, which means when you're testing a transformer at 400 Hz or 200 Hz or whatever, it will reference to that 400 Hz, it won't reference to the 50. So that's just checking that's correct. So the ranges are correct, the calibration is correct, and also the input reference is correct. That's all working.